Hey, hello everyone. Today we are going to solve this daily problem from LeetCode, kth largest element in an array. So we have been given an integer array nums and an integer k, and we have to return the kth largest element in the array. So the number can be repeating, and we do not have to return the kth distinct element but the kth largest element in the sorted order. So the array given to us is unsorted, and since it asks us to solve it without sorting, so we need to do it in less than n log n complexity. So the first approach could have been sorting and then returning the k minus 1 index element. So that would have been brute force, but we have been asked not to do that. So instead of doing that, we can make use of heap. So in C++, a heap is implemented by making use of priority queue. So I am running on a very low internet speed today, so bear me for that. So as you all know that in C++, the priority queue is implemented by default is a max heap. So to make it a min heap, we will just insert every number multiplied by -1. So the negative of a very big number is the smallest number. So in that way, the heap becomes min heap. So what we will do is, first of all, we will insert the first k numbers into our heap. So for example, here the value of k is 2, and we have been given this array. So we will first of all insert the first two elements. So it will be like, for anti I equal to 0, I is less than k, I plus plus, we will just push back whatever number we get. And then to implement a max heap, what we will do is just negate the number. So here we are implementing min heap by multiplying the number with -1. Fine. So now we have k numbers in our priority queue, and since it is a min heap, so the smallest number out of the k number stored in the queue will be at the top. So we get that the kth the kth number is at the top itself. Now first of all, we will be pushing 3 and 2, and it will be pushed with complexity log n. So we are doing this twice, so it becomes basically the size of the priority queue is k, so it will become log k and 2 times log k. So now after that, we will be having 2 at the top and 3 at the bottom. So if we had not multiplied it minus, then it would have been 3 comma 2, but since it becomes -3 and -2, so -2 is a greater number, so -2 will be at the top. So this is how we are implementing the min heap. Now we don't how do we know that this is the kth largest number? So to compare the remaining number, we will just start our iteration from anti I equal to k, and I is less than nums dot size, and then finally I plus plus. So we will iterate through the remaining array, and what we will see is, if the current number is greater than the top number, then we will just replace that number with that number. So if we already have the k largest number, then no other number will be greater than the number at the top. Otherwise, if it is greater than that, we will just push back that number into our priority queue, and it will get arranged in that queue based on what its value is. And we always know that whatever the values that are stored in the priority queue, the kth largest number will be at the top, because it is a min heap, and we have stored all the k largest numbers. So the smallest out of them will be the kth one only, and that will be at the top. So we just need to compare that. Any other number below that will be obviously greater than that number, and we don't need to compare with them. So here what I'm trying to say is, we will just take out the topmost element, pq dot top, and also when we are popping it out, we'll just negate it as well. And if this number is smaller than the current number, then what we will do is pop out that number and then push the current number. Now what else is minus sign? So this number will get into the priority queue wherever based on its value, and at the end what we will return is the topmost value itself, top and the minus sign. Let's try and run it. So this gets accepted. Let me show you. First I'll submit it. So this gets accepted with a good enough speed, and we are using O of k space complexity and n log k time complexity. However, we can also use quick sort here, and then choose any random pivot value from the starting and the end position, and then replace all the numbers smaller than that to the left and greater than that to the right, and then finally check the position of the pivot. If it is k, then we will return it, otherwise we'll just repeat the process. So that can be another approach which has a complexity of on in best case and on square in the worst case. However, it is mostly a linear approach and we do follow that sometimes, but this is a very simple approach to understand, even though it is taking a bit of memory. So just to make it clear, let me also give the try run. So for this array, we have first of all -2, -2 and -3 in our priority queue. Next, when we will go to the kth position, that is 2, so that will be 1. So 1 is smaller than 2, so we do not do anything. Then we go to 5. So what we will do, we will pop out 2 because it is smaller than 5, and we will insert -5 in it. So pop 2 and push 5. So our priority queue will now become -3, -5. So -5 will automatically get heap sorted and placed at the end. Now we come to this. Okay, let me write it here as well, so it will be good. 3, 2, 1, 5, 6, and 4. Now the number 6 is also greater than -3, the number 3. So we will just pop out 3 and push 6. So this will make my priority queue as -5, -6. What next? 4. So 4 is smaller than 5, so we do not need to consider it. So as you can see that the priority queue is maintaining the size of 2, and we are considering that we have the greatest 2 elements in our priority queue. If the number at the top is not greater than the current number, that means this number should be in the top 2 numbers. As for example here, 5 was greater than 2, so 2 should be removed and 5 should be inserted in the queue. Now we consider that 3 and 5 are the top 2, the greatest 2 elements of this list. Next we compare that 6 with 5 with 3 and see that 6 is greater than 3, so 3 is again popped out and 6 is pushed in. And as we are using a priority queue, it all automatically sorts it, and whatever the value is at the top is the smallest of all of them. And since we have to return the kth largest element, we'll just start counting from the end. So 1 and 2. So the top element is always the kth largest element. So this is how this logic works, and this is a very basic question of heap sorting that you should know. So hope you like the solution, and see you tomorrow.